You okay, dogs? I'm just going to make sure it works. My other link over here. There you go. Okay. All right. I didn't hurry here. One, because I was still putting my little girl to bed, and two, I have 3 questions, which is fine. So I'll just get started. What is a formula unit? Okay, that is the first one, and I'm going to answer it by drawing a picture. So let me see if I can get my screen to share. Okay. All right. Okay, that is the first one, and I'm going to answer it by drawing. All right, here is my answer to that one. So a formula unit is basically, if you had to pick, it's an ionic compound. So in that upper box, if you have something that's an ionic compound, like KCl, NaCl, calcium carbonate, that would be called a formula unit. And here's the reason why. When you take ionic compounds, they're like those balls that stack up on top of each other. So that would be like maybe the cation, and here's the anion. It's bigger than the cation. And they stack up on top of each other. But remember, it's really hard to tell which one, like if this is NaCl, which Na goes with which Cl. My green ones are my Cls, and my red ones are my Nas. So you would have to ask yourself, like, does this Na belong to this Cl, or does this Na belong to this Cl? And it's really impossible to know. And so that's why they kind of call these things formula units. They say that this is the formula, and in this big stack of balls, or cations and anions, this is maybe what they're picking the unit to be. And then this would be the other unit, and this is another unit. So in that way, they have a unit that makes up the formula, and that's why it's kind of called the formula unit. It is the smallest whole number ratio of the ionic compound that's possible, and that unit makes up the formula. So that is called the formula unit. All in all, you have to know that formula units are used when you have an ionic compound, and that's like the label you'd use. Just like H2O is called a molecule, NaCl is called a formula unit. Okay, I gotta move this screen. Does objective 1, I can explain how mole, put my time in. I can explain how mole is used to indirectly count the number of particles of matter. Does that mean you just know how to use stoichiometry? Kinda not. I'm gonna go to my objectives here, I think. Where do I have it? In here? Yes. So this is number 2 is more all about I can use the mole map. Number 3 is I can do those really long problems when they've got limiting reactions and excess reactants and all that stuff. And then number 4 is I can formulate a question for things. I think that one's kind of self-explanatory. This one is kind of like the coverall of, you know what a mole is and why we need it. Like a mole is used to indirectly count the number of particles of matter. In other words, if you had a bunch of eggs in cartons. Go back to this video. So if you had a bunch of egg cartons, so you have one egg carton, another egg carton, another egg carton. You have 3 egg cartons right there, and they're completely filled with eggs. You would say, I have 1 dozen, 2 dozen, 3 dozen. You have 3 dozen eggs. And that word dozen, you just automatically know is 12. So in that way, you're using the word dozen to count things. I have 3 dozen. If you told someone you have 3 dozen, they go to themselves, oh, 3 times 12, that makes 36. So I have 36 eggs. Well, mole is the same idea. You could say I have 1 mole, 2 moles, 3 moles. And a scientist would know, okay, if I have 3 moles, that technically means that I have 3 times 6.022 times 10 to the 23rd atoms. So that would be how you indirectly count. Remember when we watched the video and it talked about how you don't go to the meat market and say, I would like 22 slices of bologna. You say to them, I would like a 1/4 pound of bologna. Well, that's the same idea with a mole. You don't go to them and say, Scientists don't go and say, I would like 2.3 times 10 to the 32nd atoms of carbon. They go and they say, I would like 26 moles, or however many moles that they want. So in that way, we're counting the number of atoms, but indirectly by using this term mole. So knowing what a mole is, knowing that would be what a mole is, knowing that it's a counting unit, knowing that it's a counting unit for a big number, knowing that we can use it to find mass of things, because the periodic table is so handy that it has the molar mass on the periodic table, which tells us how many grams we need to just have a mole of a substance. Those kind of ideas. Yes, that's what I think. That's kind of what that one's talking about. All right, and to my last question. What is molar mass? Molar mass is the mass in 1 mole of a substance. So in other words, it's like on your periodic table. If you look up lithium, it says 6.941. That's its molar mass. Molar means the mole. Mass is in grams. It is the mass in 1 mole of that substance. It is the mass of 1 mole of that substance. So if you wanted 6.022 10 to the 23rd atoms, it would cost you, according to this lithium, 6.941 grams to do that. It is the mass of 1 mole. It's kind of like, we didn't really cover molar volume. Never mind. Not going to go there. We didn't cover that part yet. That's in future unit. Just going to stop there. Okay. Those are all my lovely questions. Well, I said, like on my review, I would be there till 8:45. And I will be. That gives me 15 more minutes. I didn't anticipate too many questions here. But I think I'm going to leave you, and I got to do some paperwork that I got to get. So I will just write in here that I'll check back. I'm going to do some dishes really quick. And I guess if there's not, then I'm kind of going to end the video right there. So, I'm going to take the dogs out too. So enjoy looking at my office area. I'll be back in 5. 1:30, okay. Hey, puppies. Hello. All right, I'm going to call it. Good night.